looks like everyone's been able to get connected to audio. Um, I'm reminder to mute yourself if you're not speaking, but my name is Kelly McGregor and I am the communications lead for the Geothermal Collegiate Competition. I'm here at the National Renewable Energy Lab, and we administer the competition on behalf of the Department of Energy. So we're so happy to have you all competing in the technical track this year. And this is one of our webinars that we do to kind of highlight resources available to teams. So we are very, very excited that Josh Sellers is here from Sequent today. Josh is a project geophysicist with Sequent, and Sequent is an in-kind sponsor of the Geothermal Collegiate Competition. So they donate their software, Leapfrog, which Josh will be walking you through today. They donate licenses for teams in the technical track, and this is really a great opportunity for folks to get their hands on working with this modeling tool that a lot of people in the industry use. So we are just so happy for their partnership, and thank you to Sequent for coming back as an in-kind sponsor this year. So I'm going to hand it over to Josh. Josh is going to walk you through, I think, the basics of how to get started with Leapfrog. So with that, I will hand it over.
Thank you so much, Kelly, and it's great to meet everyone. Super excited about this geothermal collegiate competition and always happy to sponsor. So today, in the next probably 25 minutes, we're going to do a very brief overview of Leapfrog. But before we actually do get into the application, I'm just going to direct you to some self-guided learning material. So this 20-minute brief demonstration is not going to cover absolutely everything that you might want to know about Leapfrog, but it will enable you to actually just open up the software and kind of get things kicked off. But there's a lot more that you can do besides just the quick couple of things that I'll show you in the next 20 minutes. So through my.sequent.com, you have a portal of a few different things. The first step is, most importantly, if you haven't downloaded the software yet, through my.sequent.com and signing in through your Sequent ID that's got your Geothermal Collegiate license registered, you can go to the downloads page, and this is where you can download the latest version of Leapfrog Energy. You simply press download, sign in with your Sequent ID, and that's going to download the application to your desktop, which you can open and then run and create models from your data. The next important spot is this Learning tab. This Learning tab, if you press it, will take you to the LMS. That's the Sequent Learning Management System. This will have some detailed courses that will take you through from start to finish, basic and more advanced workflows that you can utilize with your own data. All of our courses are data-driven, so similar to the data set that I'll walk you through today. The steps and the processes described in these different course manuals will they'll have a data set provided, so you can simply just follow along. To get to the relevant learning material from the catalog, you generally get to this home page where you have access to some of the courses that you may have registered for in the past. If you go to the catalog option and scroll down to the middle where it says explore your learning options, and you search here for energy, you can register for the Leapfrog Energy Fundamentals. It's one of 8, and it would probably take about 8 hours to complete all of these different 8 different portions of the course. By the time you finish these 8 courses or 8 portions of the course, though, you will be basically Leapfrog experts. So this would lay the foundation for actually being able to work with your own data sets. So I'd strongly suggest that you do dedicate some time to walk through this. It's a great learning exercise. But before that, we're actually going to walk through some of the processes that will be covered in this in a very quick session. So the first step is to open up Leapfrog. So from the application, it's opening up on my other screen right now, but I'll just drag and drop it to this screen once it does open. But it's like any other application. You simply just double click the icon or search for Leapfrog in the search menu of Windows. So once Leapfrog opens up, you're going to get prompted to check your browser. And your license is going to be associated with your Sequent ID email address. So this is the first step in actually opening up and using Leapfrog. It's going to take you to this license chooser where you're going to have your name, an organization, and the group and product that you're going to be working on. The licenses have been assigned to a particular organization. It's probably called something like Geothermal Collegiate Competition, but it's very important here as the first step that you choose the correct organization. The default option is going to be your name, but your name only connects to the free Leapfrog viewer. So although you're able to view files that have been created in other Leapfrog projects, you won't actually be able to create and interpret your data within this Leapfrog viewer. So generally speaking, when you open up Leapfrog for the first time, the organization is going to be set to your name. This is a default organization that we generate that allows you to open up the Leapfrog viewer. So first step is to switch this organization to the organization that has your Leapfrog license associated with it. So I'm going to choose this one. And here you can see that the product is now Leapfrog Energy, which means that I can open up and use the commercial application. And I'll press Get Started. Open Sequent Connector, and if you don't want to see this pop up every time you open up the application, you can simply just double or click this and turn it on. So we'll open Sequent Connector. And whoops, I've actually got an error, so I'm going to have to redo that process. So bear with me just a moment. Might have been because I was talking too much as I was actually choosing the license. Actually, give this just a second while I'm choosing the correct license. I think I might have chosen the incorrect one. Perfect. All right, sorry about that, folks. Quick little hiccup. All right, so once you actually open up Leapfrog, this is kind of the user interface. You'll see the different central projects that you may have access to, just going along the bottom right there. You'll have a projects tab, and you'll also have a scene files tab. So scene files are Leapfrog viewer files, but once we actually start to create our own project, there's going to be a third tab right here called the scene view, which is where we're going to be interacting with and creating 3D objects. The first step in this process is in the top left corner under Leapfrog Energy, which we see up top here. We'll left click and create a new project. We're going to navigate to the folder where we've saved all of our data. And we're going to create a new project in that folder. And we'll call this one GRC Live. If you're working off of OneDrive, you will get an error. This is simply a warning to suggest that you do not work off of OneDrive. So I'll work off OneDrive today just to show you what happens when you work off OneDrive. And the reason that we suggest that you don't work off OneDrive is because it does, OneDrive has a tendency to overwrite and potentially corrupt Leapfrog models. So if you wanted to avoid any of those potential pitfalls, I would suggest you work off of your C drive. So we'll press OK, but we'll work through this today. But I wanted to show you this just as a warning. So the Leapfrog Energy user interface. On the left here, we have the project tree. We've designed Leapfrog in the most intuitive way possible. So we don't have a ton of hidden folder structure menus. If you wanted to simply import data, you go to the project tree and locate the folder that is representative of the data set that you want to import. So for topography, you could right-click topography, and you can simply import topography from a new object. Similar to drilling information, you would locate the folder that's representative of drilling data, so well data in this scenario, and everything is accessed by right-clicking, so we can import wells. Designs, points, polylines, geophysical data, meshes, and so on and so forth. So we've got a very simple project that we're going to open up today. We're going to start with topography, import some well data, and then we're going to create a geologic model and a 3D temperature model from the imported data. We can import through topography, or if you have a mesh such as a DEM or a DXF that you wanted to import as a mesh, you could import that through the meshes folder. So you have two options here, through topography or meshes. I'm going to import through the mesh for this quick example. So to import a mesh, which is simply just a 3D triangulated surface, you can right click and import mesh. You have two options, local or elevation grid. An elevation grid is going to be a geosoft.grd file, whereas local is going to have a few more options. So we'll choose local, we'll jump up a folder, and we'll go to this topography folder. I will note as well, this session is going to be recorded. So we're going to kind of rip through a couple of workflows, but Kelly and the team at NREL are going to send out this recording, and we'll also send out the data set that we'll use in this recording if you did want to repeat any of the processes that we look at today. So the cleanup mesh, generally speaking, I will simply just keep the defaults, and if anything looks incorrect with the mesh, I'll go back and re-import and have a closer look at these options for the steps. So we'll press OK, drag and drop our topography in, and then this is a mesh in 3D space that shows triangulated surfaces in this 3D scene. So a quick tour of the user interface. In Leapfrog, we have the project tree right here. So this is where you can import data. Everything is accessed by right-clicking. Once you get a data set into the project tree, you can right-click that object, and that will open up additional options for additional processing steps on that particular object. To visualize an object in the 3D scene, it first has to be brought into the project tree, but then you can simply left-click, drag and drop, and visualize that object within the 3D scene. You'll notice that underneath, we now see this object in this panel right here, and this is the shape list. So this is a list of shapes that you can visualize within this 3D scene. So as we have more objects, we can start dragging and dropping, and you'll notice that this shape list continues to expand. The shape list allows you to define how the objects are visualized within this 3D scene. So we can turn on and turn off using this little eyeball button, so show shape. We can remove it from the shape list using this little X. We can also change the values that are displayed. We can go values, dip azimuth, base dip, or simply just apply a flat color. And here's where we can also change the color associated with the values on our mesh. So we can left click and we create a new color map, or you can simply adjust the existing color map. So I'll just show you very quickly how we can change how this is displayed. We'll create a new color map. We'll choose continuous, and we'll change this gradient to something like linear, which is probably more representative of topography. The histogram right here, we can change, simply drag and drop, or we can generate a new curve by increasing the number of lines. So we have 2 points right here, 3 lines. We can change the number of lines, press apply, and that will adjust the how this histogram relates to the colors associated with each bin. If you left click on an object in the shape list, that will show that object in the properties panel, and this will define how we can how this object interacts with slicers, that we can slice and dice objects in these 3D scenes. And it'll also allow us to apply filters for numeric data. So although this is called topography right now, this is simply a mesh in our project. There's also another folder called topography. In Leapfrog, you can only have one topography in your project, and the topography is a special mesh that acts as the air-earth interface. So what do I mean by air-earth interface? Essentially, it cuts anything above this particular mesh. So although this is called topography under the meshes folder, it's not actually registered as that special mesh until we come up to the topography folder, right-click, and register that surface as a topography. So now we've got 2 copies of this particular mesh. One is simply a mesh that represents a surface. The other one is a mesh that acts as the air-earth interface when we're creating 3D objects. So the next step is we're going to bring in some drilling data. We'll right-click the well data folder, press import wells, and we have a couple of options here. But for this one, we'll choose local. And this just allows us to import something from our local desktop. So we'll left-click local, and this shows the import wells dialog. At minimum, you need a location, a survey, and either an intervals or a point value. If anyone's unfamiliar with the terminology here, I'm just going to break it out into Paint really quickly. So you have a location file. This green line represents topography. The location is going to show the X, Y, Z information of the top of the drill hole. So the location is going to show the point of that well on topography. The survey file, which we'll show in red, the survey builds the 3D well trajectory, so the drill hole trace downhole. So at particular depths, it's going to show a dip and azimuth. And as that dip and azimuth at a particular depth changes, that will also change the trajectory of that drill hole. Then we have points and interval files. So points are simply data points. So it can be numeric or categorical information at a measured depth along this drill hole. So measured depth means that along this drill trace, even if it curves at a depth of about 50 meters, at 50 meters as we go down this drill hole, there will be a point associated with some sort of numeric or categorical information. So if you had a points file that had a value at 50 meters and 150 meters, you would have a value at 50, and then as we go down and measure 150 meters along the directional track, you would have another point. And we also have interval files. So an interval file shows a from, to, and this can be categorical or numeric information. But from a depth, let's say, of 0 to a depth of 100, you have some sort of category. So this shows up as a bar along the well trace. So from a measured depth of 0 to a measured depth of 100, you have a particular category. Same thing, if you go from 100 to 200, you have a different sort of category along the measured depths along that drill trace. And I guess this should actually be a bit deeper because this represented 100. So that's how these data types are structured. You choose your location, you choose your survey, and then you need some sort of interval or point data along with the 3D well trajectory. So we'll choose location, jump up a folder, go to our well data folder, and we have a location file. This reads the naming conventions that I have in this folder and automatically assigns the survey and the geology as survey and intervals, but will also import temperature as points. And pressing import will just give a quick review of the types of columns and the associated data types with these drill hole objects. So if we just jump back to Paint for a moment, this is a relational database. So these 4 different files, the location, the survey, the interval and point files, are all related by a hole ID. So this column is going to be consistent with all of these 4 different data types, which is going to enable the 3D well trajectory, the measured depth along that 3D well trajectory, to be related to the XYZ location of our collar file on topography. So you'll see here that we have a well ID with these different names associated with them. So each one is a unique drill hole. We've got an X, Y, Z, and a depth column. So maximum depth along this collar. And those are the 5 critical columns that we need for building a location table. If we press next, we're going to jump over to the survey, and you can see that on top right here, the progress. We go location, survey, interval, points. So we've got a well ID. this relates this information to build that well trajectory to the geospatial information that's on this location table. So the well IDs, the names here, have to be consistent with the names associated with our location. We've got a depth. So at a measured depth, we have a dip in azimuth, which allows us to build a directional 3D well trajectory. We'll press next one more time. Again, common theme, we've got this well ID. We've got from, to, and some sort of categorical information. So this shows that at a measured depth from 0 to 69, we've got these different lithologies that have been logged. So we'll choose this and import it as category. Category and lithology are essentially interchangeable in intervals. Categories and lithologies allow us to build geologic models from them. We'll press next, and we'll also import the temperature as numeric data. Obviously, these are numbers. Numeric data is going to allow us to build 3D property models, and we'll press finish. So this builds the 3D drilling object. And if we expand out the well data folder and expand out the wells, you can see that there's multiple objects associated with this drill hole object. So we've got a location, which we can drag and drop into the 3D scene. Using the tools available in the shape list, we can make these solid. And then if we click on it in the shape list, we can go over to the properties panel and we can increase the size. We can also look at the traces. So the traces are built from the survey data. We'll look at the geology file. So these are intervals associated with the categorical information. So each one shows an interval from to with some sort of categorical information. And we can also look at the temperature values. So there's a few different things that we can do to optimize how these objects are visualized. We can make these points solid. You can click on the object in the shape list, and then in the properties panel, if there's some sort of numeric data associated with the data that you're looking at, you can change the radius values to reflect the range in values associated with the downhole objects. So Leapfrog is a fantastic tool for allowing you to visualize and interrogate objects in 3 dimensions. You can see here that the drill hole SD09 was logged incorrectly. It was logged about 1,000 meters above the surface. So if you do find that the drill hole objects that you're working with your own data have been, there's some sort of errors associated with them, Leapfrog has a ton of tools that allow you to fix those errors. So we can simply drape the location of this drill hole object, or this location of SD09 onto topography. We can right click location, set elevation, and we can set this to topography. If you wanted to clear all of the objects, you can simply press this little garbage can button in the top left of your 3D scene. It doesn't actually delete the objects, it simply just removes them from the scene. So from these group lithos, if you have a nominal color scheme that you wanted to share between objects, you can define the colors associated with each one of these. For the sake of time, I'm simply going to import a pre-existing color scheme, which is going to be consistent with the colors associated with each rock type. If you needed to change any of the colors, you can simply press Edit Colors. Let's look at rhyolite, for example, and you can click the color associated with rhyolite. And then you can simply assign some sort of custom color. So we can maybe go this pale red, and that will adjust in real time. To create a geologic model in the project tree, simply scroll down, right-click Geological Models, press New Geological Model, choose the Base Lithology column. So the base lithology column is going to pull information about the lithologies that you see in the categories of your interval table. Change the surface resolution. We'll decrease this one to 100. This is the size of the triangles that are going to be used to build the meshes that represent geologic contacts. And this boundary right here can be expanded or shrunk. It can also be a variable boundary that we won't have time to cover today, but just note in your own projects that it doesn't have to necessarily be a square. We'll give it a name, press OK, and then drag and drop that in the scene. And we can see here that the topography that's been registered as that special mesh acts as that air-earth interface. So to construct representative contacts associated with these 3D drill hole objects, we can expand out the geologic model, go down to surface chronology, right-click, and then you have a couple of different surface building tools available. We have deposits, erosions, intrusions, veins, and these 3 special surfaces. So today we're only going to cover deposits and intrusions. We'll click New Deposit from Base Lithology. This is going to pull information about the drill hole contacts in your wells. We'll choose a primary lithology. We'll say basement, which is this object on the bottom here, and we'll use contacts above, and we'll choose andesitic breccia. This builds a surface that represents the contacts that we see here in the drilling information. On the back end, it's using the fast RBF, that's a radial basis function, to construct a best fit surface from the 5 contacts associated with andesitic breccia and the basement. We'll again right-click surface chronology, press New Deposit from Base Lithology. This time we'll choose ignimbrite. We'll use contacts below, and it's going to build a surface based on these 8 contacts with the dark green and the light green unit. Press OK, drag and drop, and then we've got a contact associated with ignimbrite. We'll also look at an intrusion. So deposits and erosions build kind of flat surfaces along the tops or bottoms of intervals. Intrusions will build circular objects around the tops and bottoms of intervals. So with deposits and erosions, you choose basically the top or bottom, but intrusion will enclose an interval. So we can right-click, press New Intrusion from Base Lithology, and this time we'll choose rhyolite. So it's going to build bubbles, circular objects around this rhyolite. Press OK, drag and drop. And then as a geologist, when you're going through your own data, you have to ask yourself 2 questions. Does it fit the input data? And is it geologically reasonable? So it builds circular objects around the tops and bottoms, or the tops and bottoms of this particular interval. So it does fit the input data. But if you're looking at an intrusion, it's very likely that this is going to be continuous throughout the entire project. So Leapfrog provides a ton of tools that allow you to edit and adjust the surfaces that are built from that mathematical algorithm. So we can double click rhyolite, and I'll just show you one example of the many ways that you can construct the best representative geologic surface. So we can go to the trend tab after we double click rhyolite, and we can draw a plane using this button up top. And we can stretch set from plane, so we can stretch this trend along that plane. So that connects the dots. And what we're doing there is we're applying an anisotropy. So we're stretching it in the direction of this plane, which connects those discrete circles. Then we have our geologic model, which is still kind of an unknown volume of rock. To activate the surfaces that we just built and create volumes, we can double click the surface chronology, define the cross-cutting relationships. We can activate all of those surfaces, press OK, and then we have a representative geologic model. And that's a very, very brief introduction to Leapfrog, but these different geologic units, these are representative of your different rock types. Is there any questions on this very brief introduction? Obviously, the full course will take you through a lot more. It will take you through that process with this exact same data set, but in much more detail. It will also take you through the process of constructing a temperature model.
Thanks, Josh. That was great. And I learned so much too. And I'm amazed you fit that into 25 minutes. Folks, if you do have questions, you can put that in the chat or you can come off mute. Like Josh said, we will be making this recording available so you can go back through everything he was kind of showing you quickly and retrace his steps. Other thing I am going to throw in the chat is we have about an hour-long recording from Sequent of another type of walkthrough that we did for the competition, I believe 2 years ago. So I'm going to put the link to that recording on YouTube in the chat in case you want a little more information. That would be a great one to use. And it looks like we do have a question in the chat. I'll read it out loud. It says, the training modules will provide sample data for us to use the way you use them for this tutorial, right? Is that true, Josh?
Yeah, absolutely. It's actually going to be a very similar data set, and it's going to take you through a lot more than we just saw in this quick 20 minutes.
And if anyone's having issues connecting to their Leapfrog license, I put this in the chat, but email geo.competition@nrel.gov. And then if you have already requested it and you were just waiting for your login information, a lot of times that might go to spam. So check your spam folder, but then of course reach out to us again if it's not in there.
Well, excellent. Thank you so much for inviting me on board, Kelly. Great to meet everyone, and good luck in the competition.
Thank you so much. And thanks everyone for your time. Have a great rest of the day.